With this lesson, we're going to take simplifying rational expressions and we're going to take it to the next level. Before we had been multiplying and dividing rational expressions. And what we did when we multiplied is we factored the numerators and denominators. We brought the numerators together, the denominators together, and we reduced common terms because they were equal to 1. And with division, we took the reciprocal of the second fraction and then we multiplied and then followed that process. For this one though, we want to add and subtract. In order to add and subtract fractions, we have to find a common denominator for those. So that takes it to the next level when doing these problems. So let's talk about common denominators. When we do these, we want to get the least common denominator. We call that the LCD, least common denominator. And when we do that, we want to make sure we include all the factors in both denominators. In order to do that, we take every factor, once we've factored each denominator, we take every factor that's involved, and then when we look at the exponents, we have to take the largest exponent. Now that might be a little different than what we would expect when we say the least common denominator with least, but that's because the largest exponent will ensure that both denominators are in common. That largest exponent gets us the common part of the least common denominator. So let's try it. Let's start with a problem where we're just dealing with numbers. These are problems like you've done in previous courses. So we want to find the least common denominator for this. And to do that, we're going to look at the factored form of each of these numbers. 8 is 2 cubed, and 10 is 2 times 5. Now when we look at those, each of the factors, we have a 2 and we have a 5. Well, we look at the 2's, and this has an exponent of 3, that has an exponent of 1. We take the largest, so it becomes a 2 cubed. The 5, there's only one of them. It's to the first power, we leave it that way. 2 cubed is 8 times 5 gives me 40. So 40 is my least common denominator. Now you might have known that intuitively from 8 and 10, or you might have just said, why not just make it 80? And you could, but that would mean that at the end we'd have a lot more simplifying to do. This ensures that we'll have the least amount of simplifying both during the problem and also at the end of the problem for the least common denominator. Okay, for this 1/8, its common denominator, to get to that 40, we're missing a factor of 5, so we're going to multiply it by 5 over 5. The 10 for a denominator, to get to 40, it's missing a factor of 4, so we multiply by 4 over 4. So we get 5 over 40 plus 4 over 40. Now those both have the same denominator, so we're going to put it, the result over 40, and we're going to do 5 plus 4. So we can bring the numerators together when we get that common denominator, and we get the final answer is 9 over 40. Now you should look to see if that can be reduced by any common factors, and in this case it can't. Now let's try adding in variables in the denominator. So we're going to look at this one and decide how we're going to come up with the least common denominator for it. So for this one, if you notice, 4 is 2 squared, and 6 is 2 times 3. So now I've got all the factors in factored form, and so I'm going to take the 2 as one of the factors, the 3, and I've got an x, and I've got a y. Now I look at all of them and I say, what's the largest exponent on the 2's? This is 2 squared and 2 to the first, so I take a 2 squared. 3's, there's only a 3 to the first. X's, the largest exponent is x to the fifth. And then y's, it's a y to the first, y squared, largest exponent is a 2. So when I multiply that out, 2 squared is 4 times 3 is 12. I'm going to have x to the fifth, and then y squared is my common denominator. All right, now let's go ahead and simplify, or take both of these fractions and come up with what's missing as factors. So 3x over 4y squared, I need to get to a 12, so it's missing a 3 over 3. I've got a y squared, but I don't have that x to the fifth, so I'm going to put an x to the fifth there for both the top and the bottom. The second fraction, 11 over 6x to the 5th y. Okay, I've got a 6 here. I need to get to a 12, so I'm going to make it a 2 over 2. I've got an x to the 5th, so I'm taking care of there. I've got only one y. I need 2 factors of y, so I'm going to put a y over y for that term. Now let's simplify each of these fractions. 3x times 3x to the 5th is 9x to the 1 plus 5 gives me 6th power, all over 12x to the 5th y squared, plus 11 times 2y gives me 22y, all over my 12x to the 5th y squared. Now I've got the common denominator. We can put both of them together over that common denominator into one fraction. So just list out your denominator and then combine the numerators. They're not like terms, so we're going to leave them separate. Look to see if there's anything that can be factored out and then reduced. There isn't, and so what I get is this is my final fraction. All right, let's try one now where we have, in this case, a trinomial and a binomial. The first step we want to do is we want to factor this denominator. This becomes an x plus 4 and then an x plus 5. We have an x plus 4 there. So my least common denominator here, I'll list it over here, is going to be an x plus 4 as a factor and the x plus 5 as a factor. Since I already took that x plus 4 there, I don't have to take it again, but I look at the exponents. This is to the first power. That's x plus 4 to the first power as well, so I'm already taken care of with that one. All right, this denominator already has the common denominator, so I just relist it as is. Then on the second one, it is missing the factor of x plus 5. So I multiply by it, top and bottom. Now when I look at this, I can simplify this. I'm going to take this first one, list it out, x plus 4, x plus 5. Now I can multiply this through, distribute the 9 through. I get a 9x, and then I get a plus 45. My denominator is x plus 4, x plus 5. Now be careful with these. When it's a subtraction problem, make sure that subtraction gets distributed through as well. So I get x over my common denominator of x plus 4 and x plus 5. And I can extend that out now and include this denominator, minus 9x, this numerator, subtract the 9x, distribute through the negative to the 45, so it becomes minus 45. And now I simplify. X minus 9x is negative 8x minus 45. And that's all over x plus 4 and x plus 5. We then look to see if this numerator can be factored. Is there a common factor I can take out? And in this case, I can't. If I can, you factor it and then see if you can simplify like we did originally in previous lessons. But in this case, nothing can be reduced. It's okay to leave the denominator in factored form so we can check that. Sometimes we might want to simplify it by multiplying it out, but we're going to say you can leave your denominators in factored form like this. So this is our final answer for our problem. So what we do to simplify when we're adding and subtracting is we have to look at our denominators and come up with the least common denominator. We do that by looking and factoring them, taking every factor, then taking the largest exponent on those factors to, for each of those factors to find our least common denominator, and then look at each denominator, see what it's missing from that common denominator, multiply by it and top and bottom, and then simplify your results, and you get simplified rational expressions.